Hello there, Bear Cubs, and this is the 32nd video. This video is on standard index form or standard form. Some people will just knock out that index and not use the word index in the description of this particular topic. It doesn't matter. Keywords: standard index form and powers of 10. All right, remembering what powers of 10 are is important. Standard index form is just a way of writing a number. It's just a shorthand way of writing a number. If a number is really, really big or really, really small, it's useful to use the number written in standard form to do the calculations with ultimately. But we kind of show you how to do that by writing not too big numbers or too small numbers in standard form to help you understand it first of all. Now, the method, you've got to write numbers in standard form. You need to remember that the number at the beginning needs to be between 1 and 10. So this A up here, that's between 1 and 10. There's always going to be a times 10 part, so it's always going to have times 10 to the power of something. So I've put a little power of n. Now the power is the number that represents how many places a decimal point moves. Okay, and you'll see this in the examples in action. Really big numbers have positive powers and really small numbers have negative ones. Okay, now in question 1, we've got to write the following numbers in standard form, and that is a case of thinking where the decimal place is. If there isn't one evident in the number, then it's at the very end, and it's gone 1, and you probably would like to do this in the same way. 1, 2, 1, 2, 3. That's going to keep doing that. 1, 2, 3. Yeah, it's going to do it. I'm going to 1, 2, 3, 4, 5, 6, 7, 8, 9 places. It's moved 9 places to make it 2.43. Okay, I hope you realize that 2.43 is definitely a number between 1 and 10. Okay, and then times 10 bit, always there. And then the power, because it's a really big number, is a positive 9. We moved it 9 places to make it there. Okay, now the next number is just a different number. Same thing, it's just got more digits that are not zeros. Okay, 1, 2, 3, 4, 5. Let's move 5 places to make it 3.959 times 10 to the power of, and I moved it 5 places, 1, 2, 3, 4, 5. Yeah, had to check because I nearly forgot. Now, in C, we've got a really small number, a decimal number between 0 and 1. So we're going to move the decimal 1, 2, 3, 4 places the other way. All right, we're going to the right with the decimal place now. And I'm cheating by moving the decimal place, I know. All right, but it doesn't matter. All right, it really doesn't matter. It works. So, yeah, moving that there in between the 8 and the 7. So that's going to be 8.79 times 10 to the power of, and we moved it 4 places the other way. It's a really small number, so it's going to have a negative power of 4. Okay, just got to remember that bit. You could make a mistake there. Please don't. Now, in question 2, you've got to write the following as actual numbers. Real numbers. All right, these are real numbers as well. They're just written in standard form. But actual numbers. 4 times 10 to the power of 6. That's going to equal, write down the number 4. Okay, and then we're going to move the decimal place from the end of number 4. 6 places, 1, 1, 2, 3, 4, 5, 6. So there's going to be 1, 2, 3, 4, 5, 6 zeros. That's the number 4 million. 1, 2, 3, 4, 5, 6. Now in B, we've got 2.345 times 10 to the power of minus 6. So I'm going to write 2, 3, 4, and 5 down as the digits that we've got here. I'm going to put the decimal. I'm not actually going to put it into this calculation. I'm just going to put it here. That's where it would be, or there. And then I'm going to jump it the other way, all right? Because there's a minus power, minus 6. So I'm going to go 1, 2, 3, 4, 5, 6, and then decimal plops in there. Because it's a small number, you've got to have a 0 before the decimal place. 0, 0, 0, 0, 0. Okay, there's our final answer. So 0.1, 2, 3, 4, 5 zeros, and then 2, 3, 4, 5. Okay, always just double check that you've done this correctly. So it's gone from here 1, 2, 3, 4, 5, and 6 places back, and that makes sense. Okay, let's move me over. And let's look at the third question. So 3A, write the following in the number in standard form. 72 times 10 to the power 4. At first glance, it looks like it is in standard form, right? But it isn't. This number here, remember, has to be between 1 and 10, and it isn't. It's 72. All right, so we're going to go 7.2. Right, going to take the decimal place and move it back one space. If we've done that, then we're going to have to do something to the power. Okay, now what's going to happen to the power is if we've divided this by 10, we're going to add 1 onto the power. Okay, so that's going to be 7.2 times 10 to the power of 5. We need an extra power of 10 to get back to this 72 times 10 to the power of 4. All right, remember if you took powers of 10 are numbers that are 10, 100, 1,000, 10,000, 100,000, etc. Okay, so 72 times by 10,000 is the same as 7.2 times by 100,000. All right, I hope that makes sense. I know that's starting to get tricky and sound tricky. But then in the second part of A, we've got to go the other way with it, because this number is not between 1 and 10, is it? 0.089 is less than 1. So we're going to go 1, 2 to make it 8.9, and then times 10 to the power of, well, because we went the other way with it there, right? We made it bigger. We're going to take 2 numbers off of that power, moved it 2 spaces the other way, so that's going to become a power of 3. Okay, so I don't know why I didn't write the answers down there. That's where the answer should have been. Now, B, this is just a worded problem, but actually it's pretty simple. The distance between Southampton and Glasgow is 428.5 miles. Look that up, it's actually real. Write this in standard form. Okay, so let's put that number, that decimal place, number between 1 and 10. So it becomes 4.285. 4.285. We've moved it 2 places back, so times 10 to the power of, and it's a big number. It's not a 0 point number, so it's gone back 2 places. There you go. There's our answer. That's it in standard form. Okay, it's just a worded one. People find those difficult sometimes. But there you go. There's the skills you need for standard form. There will be a video on calculating with standard form after this one. That is a higher level of stuff. That's grade 5 stuff. But yeah, this one hopefully will get you somewhere at the beginning of the topic. Watch the other one straight after this one if you want to, because it will be on there. All right, like and subscribe to the channel, and click the link in the description to practice some things when it's there, and there'll be answers and all sorts. All right, have a lovely evening. Bye bye.